Hello everyone, hi, welcome to the fourth part of the integration topic. So today I will cover this is the fourth part and the last part of the integration topic we have. And so today I'm going to do the numerical integration, and which is finding the area under the curve using the trapezium rule. Integration as a limit. The area under a curve can be split into strips. So think about how you may have measured areas of circle when you were young using a grid. So what we mean by this, I'll just show you here. So this is like the circle here, and you split it maybe when you were young, just an approximate area. It's not an exact area basically. So if you just draw rectangles, that will give you approximate area of the circle. Okay, so the area of each strip can then be approximated by two rectangles, one of the above and one below the curve, as it's shown here in this figure. So this is the one which is above the line, and this is below the curve, yeah, above the curve and below the curve. So as you can see, this rectangle here below, yeah, here it's below the curve, and on the other one it's above the curve. And okay, right, so and the exact area basically of the strip, it's under the curve, lies between the area of the two rectangles. So as you can see here from these two shapes, yeah, each strip can be above or below the curve, but the exact area basically it lies between the area of these two rectangles. So the actual shape we will need is basically this, which is under the curve, yeah, and without losing this bit. So if this is the if this is the curve here, and we have this is the strip, if we take it as a rectangle here, we will lose this bit from it. Yeah, let's make it clearer. We will lose this bit from it. Okay, so basically we need to take it all. So that's why the area is in between. It's not above, not below as a rectangle, but it's a trapezium shape. Okay. Okay. So when finding the exact integral is difficult, that means that when we say exact integral, that means using the integration we know, yeah? So when it's difficult to use the exact integral, we can approximate the area under the curve using strips shaped like trapezia. So if it's difficult to find the area under the curve using integration, we can use the trapezium method to find the area under the curve. And this is called numerical integration. And now we will learn a method of a numerical integration, which is called the trapezium rule. Okay, so the trapezium rule. The area under the curve is divided into a number of strips of equal width. Yeah, so if we have the curve, and as we said, we can divide it like into a number of n of strips. So the area under the curve is divided into a number of strips of equal width, and the top edge of each strip is replaced by a straight line. So the strips becomes a trapezium. So basically, if we have a curve and they draw. So this is the trapezia now. Okay, so basically if we have, this is the x-axis, y, and then we have a curve here, and it's been divided into a number of trapezia. So n number of trapezia, and there is a limit from A to B, and these trapezia, it has the same width. Yeah, so let's call it h here, the width. Okay, so this is trapezia. Okay, so they have equal width. Then go back to the slide. So the top edge of each strip is replaced by a straight line, so the strips become trapezia. And from before, if we know what's the area of each trapezia, yeah, like, which is the area of each trapezia, if this is y, I'll just go to another page. If we have this trapezia, okay, and this is the width h, and this is the two sides, let's say x and y, then to find the area for the trapezia is the average of the average of the sum of the parallel sides multiplied by the distance apart. So that means the average of these two sides, which is x plus y, divided by 2. So that it's half x plus y multiplied by the width, yeah, which is the distance apart, means the width between them, which is multiplied by h. Okay, so the area is 1/2 x plus y multiplied by h. If the trapezium was called as, the sides of the trapezium are called, let's say, oops, excuse my drawing. Oh, okay. So if that was called as y0 and y1, then the area in this case is going to be 1/2 y0 plus y1 multiplied by h. Yeah? Right. Okay, and the total area of the trapezia gives an approximation to the area under the curve. So basically, we will have a number of trapezium, and when we add them, the total sum for the area of the trapezia will give us approximate to the area under the curve, will give us approximately the total area under the curve. The formula for the area of the trapezium is the average of the parallel sides multiplied by the distance apart. So that means half y0 plus y1 multiplied by h, which is the distance apart. Okay, the average means you add them together and divide by 2 in this case, because they are two sides. Okay. So just write some notes here. Just to show you this. So if we have, suppose we didn't know the integral to find this area, which is the green area here under the curve, then we can use the approximate to find this area. So the first thing to do in this case is to split the area under the curve into n number of equal strips. Okay, and each strip will be of width the width of each strips, we find it from b minus a divided by n. So b and a are the limits, like from where the area starts and end. So it's basically the length of or the width of the interval between a and b, and divide by n how many splits, how many strips. Okay, so h, to find the width, we do b minus a divided by n. All right, and also to find, we'll show you maybe later with the examples, what we need to know is the area of each trapezium. So now we know this is the average sum of the parallel sides multiplied by the distance apart, which means the x plus y divided by 2, or a plus b divided by 2 multiplied by h. Yeah, so as we explained there, just write it down here as well. Okay, so this is y1, this is y0, and this is h, which is the width. Then the area equals 1/2 y0 plus y1 multiplied by h. Okay. In this example here, the integral from 0 to 1 of 1 over 1 plus x squared dx. So this is not easy to find using the integration. So we are going to solve this question using the trapezium rule. So suppose we have 5 strips here. So this is, that's 1, and that's another one, so that's 2, 3, 4, and 5. So suppose we have 5 strips here, and the parallel sides of the trapezia are the y values of the function. So these are the y's, the blue lines here are the y's, which is the height of each trapezia. Okay, and because this is the value here, which start here, x equals 0 here, here is x equals 0. Therefore, this is the first value. When x equals 0, then the first height is y0, and the first one. So the area of the first trapezium, as we said, because the area in general of the trapezium is 1/2 x plus y divided by 2 multiplied by h, which is the width, then in this case, the area of the first trapezium is going to be 1/2 multiplied by y0 plus y1, because these are the sides of the first trapezium, multiplied by the width, which is b minus a divided by n. Okay, how to find h? We can work it out. H equals b minus a divided by n, and b here is 1 and a is 0, divided by n, which is 5. Okay, so 1 minus 0 is 1, divided by 5 is 0.2. Okay, so this is the width of each strip. So therefore, that's why they multiplied here by 0.2, because h is 0.2. Okay, so this 0.2 is basically h. Okay, now, yeah, which is the width of the strip. Okay, the area of the second trapezium now, as you can see, so the two sides on the second trapezium is y1 and y2. So in this case, the area of the second trapezium is going to be like A2 here, the area of the second will be 1/2, then y1 plus y2 multiplied by h, yeah, which is 0.2. Okay? So I'll just take this away. Right. So, and so on. So the area for the third trapezium is going to be like A3. In that case, it will be 1/2, and then in the A3, like the third strip, is y2 plus y3. So it's y2 plus y3 multiplied by h, which is 0.2. Okay, so multiplied by 0.2. And you carry on until we reach the last one. So for each value of x, we calculate the y value using the function and writing the value in a table. So usually the best way to do it is using this table. You put the values of x to find the values of y. How to find the values of y? You substitute in the equation of the question. Like y here is 1/1 plus x squared. And the thing is, x is not always be given to you. Yeah, so you need to find x. Right. How to find x? Basically, you look at your limits. Yeah. So our limits here in this question, we have the limit from 0 to 1. So the limits here are 0 and 1. So that means x naught, that means, So that means x naught equals 0. This is the first value to start. And then, because if you look at the graph here, so this is the 0, and then there is a width here, which is h, okay? And the value of h, we said, is 0.2. We found it already, yeah? So therefore, the next value, x1, is going to be 0 plus, or x naught, yeah, plus 1h. So that will be 0 plus 0.2, which is 0.2. And the second x, the second value of x is going to be x naught, yeah, the 0. And how many h here is going to be 2h. Yeah, so in this time it's going to be 2h for the second value. This and that, the red ones. So it's going to be x naught plus 2h. So that means 0 plus 2 times 0.2, which is 0.4. Okay, and the third value, which is x3, is x naught again, plus how many h? 3 of them, yeah? So plus 3h, which means 0 plus 3 times 0.2, which is 0.6. So that's why we got 0.6 here. And then same thing, the x4 is x naught plus 4h. So that's 0 plus 4 times 0.2, which gives you 0.8. And the last one is x5 equals x naught plus 5h, which means 5 times 0.2, and that gives us 1. Okay, so that's how you find the values of x. You don't expect to be given the values of x in the exam. Maybe you will need to find x in the exam, maybe. All right, so if you need to do that, then, well, actually, maybe you're not given you need to find out how to find the x's. right? So basically you need to find h, and then the limits, it's always going to be there for you. Then from the limit you just add the h until to find the x values, and after you find the x's you put them in this table, and now we will find the y. So first of all, when x is 0, we'll find y naught. So when x is 0, that means y0 equals 1 over 1 plus 0 squared, which is 1 over 1, which is 1. So that's why we got 1 here. Okay, so y1 is 1 over 1 plus x1 squared. Yeah, so that means 1 over 1 plus, what's x1? The x1 is 0.2, so 0.2 squared. And if you work this out, you should get like 1 over 1 plus 0.2 squared. Then you should get, as this in the table, 0.9615. Okay, and same thing, if to find y2, it's going to be 1 over 1 plus x2 squared, and y3 is going to be 1 over 1 plus x3 squared, and you carry on. So I hope that you know now how to substitute. Check these values and you should get these values in the table. All right, so to write the trapezium rule itself, we don't need the values of x2. We don't need to put them in the formula of the trapezium. We just use them to find the y. Right, let me clear the screen. Clear pen marking. Yes, right. So therefore, the integral from 0 to 1 of 1 over 1 plus x squared dx, approximately, because this is not the exact area, this is going to be approximately, it's very close maybe, but it's not the exact area. Okay, so this is approximate, means equals 1/2 times 0.2, which is the h, multiplied by y0 plus 2 times y1 plus y2 plus y3 plus y4 plus y5. You don't need to learn this by heart. You will be given the formula in the exam, so you can just apply the rule for it and solve the question. All right, but I'm just going to show you as well why this is the case for it. Let's say here. So if I'll use this here. Okay. Right. Okay, so if we say this is the area here, this is the, oops. Okay, this is A here. This is A, and this is B here, and as we said, this is H here, and that means X naught, yeah, the A is X naught, and therefore this point here, so this point here and here, these are basically like the height, which is the Y's. Okay, so this is Y, oops, sorry, didn't mean that, I meant the pen. So this is going to be Y0, this is Y1, this is Y2, Y3, y4, y5, and y6 or yb, same. Okay, so as we said, to find the area of the first one, of the first strip, which is, I'm gonna shade it in pink, yeah? I'm not starting from the beginning, I'm just using here. So this is the first strip here, okay? So the area, the first area here is y naught, well, it's 1/2 y naught plus y1 multiplied by h, okay? And the second area for the second strip, which is this one here, the yellow one, it's going to be plus the second one, which is 1/2, then it's y1, these are the sides for the second strip, plus y2 multiplied by h, plus the third one, which is the orange, and the side for it are y2 and y3. So it's going to be 1/2, then y2 plus y3 multiplied by h, yeah? And you carry on until you reach the last one here, the last strip, which, let's say, which color? Okay, until we reach this last one here, because it's, I'm not going to write them all, I just want you to get the idea. So until we get the last one here, so it's going to be plus 1/2, and then y5 plus y6 times h, okay? And the one before y5, okay, I'm just going to write it here just to show you that, okay. So just write the one before this as well. So plus 1/2, then this, the 5 one is going to be y4 plus y5 times h, okay? And so as you can see, we are repeat, like you can see, the only y comes once is the y naught and the y6. All the others, they came twice, they present twice in the, when you add the trapeziums, yeah? So you can see here y1 and y1 again, and y2 and y2 again. And if I wrote them all, then you can see them all. So that's why the last form is going to be, for the trapezium rule, is the integration equals approximately the 1/2 of y naught and yn, that's whatever, like which is b basically, yeah, multiplied by h, okay? So sorry, this is plus okay, so 1/2 of y naught plus yn multiplied by 2 of y1 plus y2 plus until n minus 1. Yeah. Okay, let's go back there. And so 1/2, and oh, I didn't put the times h there. Okay, times h, which is the width basically. Was 1/2 h times h times this. Okay. Right, so this is the formula of the trapezium. As I said, you don't need to worry about it. You will be given this in the exam. All you need to know how to apply and solve the questions about it. Okay. So what you do here, it's 1/2 times 0.2 multiplied by y0, which is 1, plus 2 multiplied by y1, and you just substitute the values from the table. Okay, you don't need to put the values of the x from the table, only the y's, but we use x to find the y's basically. And the question, the answer here is to 3. SF means 3 significant figures. So 3 significant figures, that means the 3 numbers, yeah? Not decimal places here. Significant figures means they need 3 numbers, 3 figures. So the general formula for the trapezium rule is the integral from a to b of y dx equals h, which is the width, as I said, divided by 2, and multiplied by y0 plus 2, y1 plus y2 plus y3 until plus yn minus 1 plus yn. And if you want to put the yn at the front, that's fine, nothing wrong. So you can write this if you want as the same thing. Yeah, you can write the integral from a to b of y dx equals h over 2 of y0 plus yn, then plus 2, yeah, multiplied by y1 plus y2 plus y3 plus yn minus 1. Yeah, and that's it. So n is the number of strips, and the y values usually are called the ordinates. Okay. So now, right? So there is always one more ordinate, which means one more y value than the number of strips. So if the question is saying 5 strips, that means you will have 5 values of y, starting from y0, yeah, so it's y0, y1, y2, y3, y4, and y5. So there will be 6 of them. If you have 5 strips, you will have 6 y's, okay? And the width h of each strip is given by, as we said, b minus a divided by n, which means the width of the area under the curve divided by n, which is the number of strips. And to improve the accuracy, we just need to use more strips. So how can we improve the accuracy of the area under the curve? By increasing the number of the strips under the curve. The more we have strips, the more accurate the area will be. Okay? Right. So let's look at this example here. Find the approximate value of the integral from 0 to pi sine x dx using 6 strips and giving the answer to 2 decimal places. So here it's decimal places, not significant figure. Decimal places means 2 numbers after the decimal point. Okay? Right. Also what you yeah, so we need 6 strips. That means we will have 7 y's. Okay, so the solution here, this is the formula of the trapezium rule, and this is the shape, and these are, I'm going to show you the strips. So the 6 strips, so that's 1, 2, 3, 4, 5, and 6. Okay, so these are 6 strips, and as I told you, we will have, in that case, because 6 strips, we will have 7 values for y, and I will show you this. It's basically these, the blue lines, and excuse me, so that's the first one and the last one are on the edges. So I'll show you where are they. Okay, so this is the first y here, which is the value of it is 0 basically, that's why, but it is y not here, and this is the y6. Okay, so h, yeah, which is the width of each strip, is b minus a divided by n. B here is pi, yeah, so b equals pi, and n equals 6 strips, and as I said, h is the width of each strip. Okay, what else we need to say? Yeah, and these are, so this one here is y0, this is y1, this is y2, y3, y4, y5, and this one here is y6, right? Now, how to find the values of x? So to find the values of x, as I told you earlier, we look at the limits. So our limit here is from 0 to pi. So we need to find h first, and then x1 will be 0, which is x0, plus h. Okay, so h here is pi minus 0 divided by 6, which is pi over 6, and therefore x0, as we said, it's 0, and yeah, so the top edge of every trapezium in this example lies below the curve. This is just a note to show you like the top edge of each trapezium in this curve, as you can see, it's under the curve. Yeah, therefore the rule will underestimate the answer. That means it's going to be a little bit less than the exact, of course, and we know that it is approximate, so it won't be exactly, but just telling you in this case it's going to be underestimate the answer, so we know it's going to be less than the exact value. Right. Okay, I'm just going to show you how to find x in this next slide. So what I just want to have the values. It's from 0 to pi, and h is pi over 6. So it's the integral from 0 to pi, and h was pi over 6. Okay, so x0 basically is 0, and x6 is pi. So what's x1 and x2, etc.? So in that case, x1 equals x0 plus 1h. So it will be 0 plus pi over 6, which is pi over 6. Yeah. x2 is x1 plus 2h, which is, sorry, not x1, x0. I meant. So it's x naught plus 2h, which is 0 plus 2 pi over 6. And that will be pi over 3. x3 is x naught plus 3h, which is 0 plus 3 pi over 6. And if you simplify this, 3 and 6 is 1/2, so it's pi over 2. And x4 is x naught plus 4h, which is 0 plus 4 pi over 6. Sorry, yeah. And that's divided by 2, then it's 2 pi over 3. And x5 is x naught plus 5h, which is 0 plus 5 pi over 6, which is 5 pi over 6. And x6, we already know this from the limits. So x6 is pi. And even if you apply this, yeah, I mean x6, we know it is pi because it's from the limits. But even if you want to apply like what we did here, if you want to say x6 equals x naught plus 6 pi over 6, and then these 6, they cancel each other, and the answer is pi, which we already know. Okay, so I just wanted to show you how to find x, because you might need it in the exam. You're not given the x, so you need to find it, basically. What was the function here? I think it was y dx. Okay. Right. Yeah, sorry, it was sine x dx. I was just looking at y dx. It doesn't matter. I mean, I just want to explain to you how to find the x. I wasn't solving the question, really. Just explaining to you how to find the values of x. Okay. Right. Exercise here, use the trapezium rule to estimate the area given by the integral, giving the answer to 3 significant figure. So this is the integral from 0 to 1 to root 1 plus x dx using 4 strips. So n here equals 4, okay, and the limits is 0 and 1, so that means a equals 0 and b equals 1 and h equals b minus a divided by n. So that's 1 minus 0 divided by 4, which is 1 over 4. So h here is 1 over 4. How can your answer be improved? You answer this question. Is it increasing the number of the strips? Yeah. So the more like the smaller the strips are, that means more strips is better. Okay, so if you increase the number of the strips, we'll get better results or more accurate. But it won't be accurate, basically. It just will be better, just improve the results, basically. Okay, so let's look at this. This is the question here. Using 4 strips, as we said, n equals 4, and the limits here, a is 0 and b is 1. So therefore, h equals 0.25, which means same thing as 1 over 4, you know that. And now, how to find x? I mean, I can see like it's not explained to you how to find x itself. They just put x in the table. But really you need to work it out yourself. So you need to learn how to find x. Okay? And as I explained there in the previous slide, how to do it, I can just show you here again and then I will delete it. So x1, like x naught here, because the limits from 0 to 1, so that means a equals 0 and b equals 1. So when a equals 0, then x naught equal 0. Okay, so this is x naught basically here, and this is x1. So x1 is going to be 0 plus this distance here, which is, no, sorry, I'm in the wrong place. Excuse me. Okay, so this distance here is, oops. So this distance here is h. Okay. So therefore, this is 0.25, which is 1/4. So x1, which is here, yeah, so this is x1, and this is x naught, and this is x2, this x3, and this is x4, right? So x1 is going to be 0, which is the x naught, plus h, and that's 0 plus 0.25, which is 0.25. If you look at the table, it's 0.25. x2 is x naught, which is 0, plus 2h. So that's 0 plus 2 times 0.25, which is 0.5. 2 times 0.25, which means 2 times 0.25, which is 0.5. Okay, so that's x2. x3 is x naught plus 3h, which means 0 plus 3 times 0.25, and 3 times 0.25 is 3/4, or 0.75. Okay, x4 is x naught plus 4h, which is 0 plus 4 times 0.25, and that will give us 1. And that's it. So we found the values of x, and that's we put them here in the table. So this is x2, x3, x4, and then to find y, we will apply our function. So therefore, if x naught is 0, then y naught, yeah, y naught equals the square root of 1 plus 0, which is root 1. Okay, and this is going to be 1. Right, and as you can see, the curve here is positive, so, and because it's area anyway, so it can't be negative basically. Right. Also, what is it? Yeah, so for y naught, that's y naught, sorry. So for y1, it's going to be the square root of 1 plus x1, which is square root of 1 plus, what's x1? We said 0.25. And so it's 1.25 under the square root. That should give you, as the answers here, 1.118. And same thing, y2 is going to be 1 plus x2, and y3 is going to be square root of 1 plus x3, and y4 is going to be the square root of 1 plus x4. And you find the answer, you should get the answer on this table. And then after you finish your table, then you need to write your formula of the trapezium rule. You don't just leave it as this in the table. You need to finish it off as the trapezium rule to find the final answer. Right, so the area here approximately, yeah, I need to clean the screen now. Okay, so the area is h over 2, and now you substitute the values, and so you put the values of y naught and h, which is 0.25, and you substitute the values basically for the y1, y2, y3 and y4, and after you work it out, then your answer is 1.22. So try to do this yourself using your calculator, work it out and see if you get the same answer. So the answer can be improved by using more strips. Okay, so the summary here for the trapezium rule: if we don't know the indefinite integral for a function, we can still calculate the area under the curve using the trapezium rule, and this is the trapezium rule. So the general trapezium rule is of the integral from a to b of y dx. So as you can see it here, this is the summary for it, and this is h, which is the width of each strip, which equals to b minus a over n, and b and a are the limits, yeah? So and n is the number of strips. I hope that was clear for you and easy to follow and understand. Please make sure to practice doing questions and finding the values of x and the values of y, and write it down in details, and show your work when you do it. Show your work and show the steps as well. Okay, take care, and please let me know if you have any question. Thank you very much and take care. Bye.